So I'm going to begin this cycle with a quick overview of the anatomy. Now, your germinal epithelium is a layer of simple squamous to locuboidal epithelium covering the surface of the ovary. The name is a misnomer. These cells don't give rise to the ova. They're not germinal. They migrate from the yolk sac, the ova, but it's not been changed. Wonderful. Classic anatomy. The tunica albuginea, or whatever, is a capsule of dense connective tissue. Now, those are the outer layers of this ovary. So the ovarian cortex consists of the follicles, the ovarian follicles, with dense connective tissue, collagen and stroma cells being supported. And the medulla is the border between them is indistinct, but the medulla consists of connective tissue with blood vessels, lymphatics, nerves, basically. So you can see here cortex. Where's my thing? So you can see the ovarian cortex here, the ovarian medulla inside. It's indistinct, but this is the bit with the vasculature. And these are all the different follicles that we'll get to. Now, on the outermost here, we've got, the germinal epithelium, the tunica albuginea, all that. Okay? So that's your ovary, and there's the little follicles that become the ova and things. So, ovarian follicles themselves consist of oocytes, the primary oocyte, look in the centre there, plus cells surrounding them, which are the follicular cells, and later are the granulose cells. Now, those cells nourish the oocyte and secrete estrogen as they grow larger. Your Graafian follicle is a mature follicle. It has the fluid-filled antrum, like you can see on the right there. It's ready to rupture, and it will expel a secondary oocyte. That's ovulation. Okay? Now, the corpus luteum contains the remnants of the mature follicle after ovulation. So the Graafian is when it's all there. You kick out the secondary oocyte, and you have a corpus luteum. What's it doing? Well, it stays in the ovary and produces three hormones: progesterone, estrogen, relaxin, and inhibin, until it degenerates into fibrous scar tissue called the corpus albicans. So you can see on the bottom right there, you can see the different stages of ejection or ovulation. Then there's a clot, the corpus hemorrhagicum, degenerates to the corpus luteum that secretes those four, and finally the corpus albicans. So oogenesis is the formation of gametes in the ovaries beginning prepartum. So we have the primordial yolk germ cell. It migrates from the yolk sac to the ovaries of the great journey. At the ovary, they are still 2N. They differentiate into oogonia, diploid, and then proliferate mitotically. Now, only 400 of the 2 million remain. The rest undergo atresia. Those that remain persist as the primary oocyte. On the right there, you can see the big primary oocyte. They enter meiosis 1, but they arrest. Oocytes are surrounded by the single flat follicular cells, and together they're called the primordial follicle. So a primordial follicle is the primary oocyte with follicular cells and a basement membrane around it, okay? That holds it all in place. How does each month form a primary follicle from the primordial follicles? Well, FSH and LH produced by the adenohypophysis stimulate development of several primordial follicles. Only one wins. When it becomes dominant, it secretes things that kill off the FSH mostly, and thereby you have a dominant follicle. But we'll get to that. So we've got the primary follicle there, consists of a core of one primary oocyte, then you've got the granulosa cells, the outermost of which rests on the basement membrane. That's not news. The zona pellucida is next. So as the primary follicle grows, it forms a zona pellucida between the follicle and the granulosa cells. So look on here, we've got our primary oocyte, zona pellucida, granulosa cells, basement membrane. So none of that's news. Primary oocyte, zona pellucida, granulosa cells, basement membrane. Okay, let's introduce some more players. So at the same time, we have a theca folliculi forming as the basement membrane becomes more organised. So that outermost layer of the basement membrane now has a theca folliculi accumulating around it. Okay, so how do we go from this, the late primary follicle, now that we've added an organised basement membrane, a zona pellucida, and a theca folliculi? Well, the theca differentiates into two layers. A theca interna, which is highly vascularized and secretes a ton of estrogen, and the externa, which is collagen and stromal cells. Okay, so the granulosa cells secrete fluid into the cavity, so we form an antrum in the secondary follicle. Okay, so now we've got a theca externa, which is stromal interna, which secretes estrogen. We've got the nicely organized basement membrane. We've got granulosa cells. We've got the primary oocyte still arrested, remember, meiosis 1, and now we've got an antrum forming. How is the corona radiata formed? Now, here we go. So the corona radiata is the thing that the sperm's acrosome has to pierce with all the proteases and the hyaluronic acid and things. So this is a key player. So the corona radiata is formed as the granulosa cells adhere to the zona pellucida. It forms a corona radiata. Okay? So that's important. So you can see down here that we've got a zona pellucida and then outer a corona radiata, and it's just granulosa cells sticking to that zona pellucida, and that is the corona radiata. Now we have a larger antrum, we have a Graafian cell formed. Right, so the secondary follicle grows because we get a massive antrum, and not only do we get a massive antrum, we get the formation of the corona radiata, and we're now haploid as we allow meiosis 1 to end. So because it's dividing, it divides asymmetrically. Okay, the small one is the first polar body, it's discarded. The larger one persists at the secondary oocyte, and this begins meiosis 2, but it stops in metaphase. Okay, and this erupts and is released, which is ovulation. And then we have the generation of the corpus hemorrhagicum to the corpus luteum that secretes progesterone, estrogen, relaxin, and inhibin, and that becomes the corpus albicans. How many gametes do the primary spermatocytes and oocytes give rise to comparatively? Primary spermatocytes give rise to 4, oocytes give rise to 1. Now we come to the menstrual cycle. So the 4 phases are menstrual, the pre-ovulatory, the ovulatory, and the post-ovulatory. Menstrual is day 1 to 5, pre-ovulatory is 6 to 13, ovulatory is 14, post-ovulatory is 14 to 28. There are many complicated ways to outline the menstrual cycle. This is my way. I've divided it into ovarian and uterine bits for each of the 4 phases. So, menstrual phase, you can see that FSH is dominant, it's circled there, it's days 1 to 5. In the ovulatory phase, FSH influences primordial follicles to become the primary follicles and then to become the secondary follicles. This can take months, because remember, they're vying to see who will become the dominant and therefore the secondary follicle. Meanwhile, in the uterine phase, there's 50 to 150 mils of menses flow. Declining progesterone and estrogen stimulates the release of prostaglandins. The uterine spiral arterioles constrict, so we get ischemia. Cells die, and the stratum functionalis sloughs off. Okay? Because of that estrogen and progesterone declining, progesterone increasing. So, the pre-ovulatory phase is day 6 to 13. Let's begin with the ovarian cycle, the ovarian part of it. The secondary follicle that we've got there has got a little crown on their head, and they secrete estrogen and inhibin. Okay? We have one dominant one, and their estrogen inhibin release decreases FSH secretion, causing other follicles to undergo atresia. We get a blister bulge of the antrum on the surface, and that's how we can see that it's the dominant one. So it becomes dominant quickly and then releases estrogen and inhibin to lower that FSH. Remember, FSH is still king in this pre-ovulatory phase, the first half, but it's starting to overlap, so they're coming close. In the uterine phase, so we've got serum estrogen from the blood, stimulates repair of endometrium so the SB proliferate to form new SF. The endometrial glands and arterioles spread, the endometrial thickness doubles to 10 millimeters. The pre-ovulatory phase is also termed the proliferative phase because of this much building that's going on. Now, in the ovulatory phase, in the ovulatory phase, it's day 14, we have a Graafian rupture. It releases the secondary oocyte into the infundibulum. So the fimbra grabs it into the infundibulum, then into the ampulla, where most of fertilization occurs. We have an estrogen storm, as it's referred to at this point. So what it is increase in estrogen goes to the hypothalamus to increase gonadotropin-releasing hormone and goes to the anterior pituitary gland to the gonadotrophs to increase luteinizing hormone, and obviously gonadotropin-releasing hormone goes through the hypophyseal portal system into the APG itself to the gonadotrophs to increase luteinizing hormone. So you get this luteal surge, as it's called, okay? and it causes the rupture of the Graafian and thereby that ovulation of the secondary oocyte after that peak surge. So you can go, chicken and egg at this point. So ovulation, day 14, where the Graafian ruptures secondary oocyte to the infundibulum. The Graafian ruptures because of the luteal surge, which is brought about by an increased luteinizing hormone and increased gonadotrophin-releasing hormone because of the hypothalamus and the APG because of increased estrogen. And now you can see FSH who? Because luteinizing hormone has become king. In the post-ovulatory phase, luteinizing is still king. This is day 14 to 28. So the mature follicle collapses. Basement membrane between the granulosa and the theca interna breaks down, and we now have a corpus hemorrhagicum. The theca interna, granulosa themselves, so remember that theca interna, the vascularized layer that secretes estrogen, and the granulosa below it, with the basement membrane between them, remember, it's now collapsed, becomes the corpus luteum under luteinizing hormone influence. Okay, so now this corpus luteum secretes progesterone, estrogen, relaxin, and inhibin. Okay, if there's no fertilization, usually in the ampulla, and the corpus luteum has only 2 weeks where it can do this, then it degenerates to the corpus albicans and it's just scar tissue in the ovary forever. Okay, so you get gonadotrophin-releasing hormone, FSH, LH rise due to the loss of that negative feedback. Boom. And then the cycle repeats because FSH, blah, blah. So if fertilization does occur, however, the corpus luteum will persist and will be rescued by HCG from the chorion of the embryo from day 8. Now the uterine phase, progesterone and estrogen produced by that corpus luteum, which I've circled, boom, yep, increases vascularization of the endometrium, which thickens and increases in glands, and thereby our secretion will then begin. Now there's 2 other ways to label this, right? So you can call it the follicular or the luteal phase. The follicular phase is when FSH is king, and that's in menstrual cycle, right, in the pre-ovulatory phase. And then the luteal phase is when the luteal's king, which is in the ovulatory and post-ovulatory phase. Okay? Boom. Nice and simple. Thank you.